Now, rates of change are all about how quickly one thing changes compared to another. So on a graph, this means looking at the gradient of a line. Now, in a distance time graph, the gradient gives you the speed. In a cost graph, the gradient might be the cost per item. And in a science experiment, it could be the reaction rate or the speed of cooling. So again, let's do a worked example together. Imagine a line goes from the origin to 10 and 50. So the gradient is, some textbooks call it rise divided by run. So 50 divided by 10, which is 5. Now in a distance time graph, that would mean 5 meters per second. But here's the catch. On a curve, the gradient changes all the time. So if it's a steep section, it's rapid change. And if it's a shallower, like a flatter section, then it's a slower change. And that's why rates of change reveal patterns you can't see at first glance. Is the runner sprinting? Are they slowing? Are they resting? Or is the cost rising steadily? Or is it rising exponentially out of control? So remember, graphs are not just lines, they're stories. And distance time graphs tell us about journeys. Speed time graphs show us the pace and the distance through the area. And conversion graphs translate between different metrics. And the rates of change uncover hidden patterns with the gradients. So next time you see a graph, don't just scan the numbers. Ask yourself, what story is this line telling me? Because once you see the story, that's when the maths comes alive.